This Zoom session is being brought to you by the Fractal Eternity. All right. Now for today, we will be going over section 1.3, lines, and section 1.4, solving quadratic equations. Okay, starting with a line. A line will have given 2 points on the line, x1, or y1 and x2, y2. Then we define the slope of the line as rise divided by run. Rise is how much y changes, y2 minus y1, over how much x changes, x2 minus x1. Now, the thing about a line is that you'll get the same slope given from any 2 points on that line. So we can talk the slope of a line. All right, now, given a point on the line, h by k, and given the slope s of the line, then we can ask what will be the equation for any other point x by y. So, okay, we'll get there for the slope point formula. All right, now, okay, we have a slope that equals s. Well, the slope is a change in y's over the change in x's. So x minus h over y minus k equals s. That is an equation. And then we go about solving for y. Transpose the x minus h. The book usually stops somewhere around here, but I like to go one more step and transpose the k and get y equals s minus h, all that, s times the quantity x minus h, all that plus k. That's the line through the point h by k with slope equal to s. The book will have it in the form m times x minus x naught plus y naught, or even like this, y minus y naught equals m times x minus x naught. I have a couple of problems with that. First of all, x naught and y naught are, well, they look too much like variables, but in this case, they're really parameters. And second, I have no idea why they use the word m for slope. Measure, median, I don't know. Maybe some of monte in French, I have no idea. I use s because that's slope. Easier to remember. All right, now, so that's the slope point formula for a line. Now, there's here also the slope intercept formula for a line, where we're given the slope s and the y-intercept 0 by b. Then if you plug in 0 for h and b for k, then you get y equals sx plus b. That's pretty easy, actually. So it's slope times x plus y-intercept. Pretty simple formula. I mean, easily remembered from here. Okay, now there are a couple of special cases where the line has slope 0 and is horizontal. Then if s equals 0, you get y equals a constant. Slope equals 0. So that would be the equation for a horizontal line. Here, vertical lines, well, okay, that corresponds to the equation x equals h for some value of h. The difficulty is the slope is a vertical line, therefore it's an infinite slope. So therefore neither slope intercept nor point slope formula are appropriate or workable, because infinity would make the equation collapse. All right, now, however, because we want to be able to include both lines with slope and lines with infinite slope into one formula, there is therefore what's called a general formula for a line. It goes like this: ax plus by plus c equals 0. Now, if b is 0, you get a vertical line, x equals a constant. If a is 0, then you get y equals a constant, a horizontal line. And if they're neither 0, then you get something like then you get a slope intercept formula. Also, if it's neither vertical nor horizontal, then it will intercept both the x-axis here and the y-axis here. And that enables you to graph the line, because it intercepts the x-axis, where when y equals 0, ax plus c equals 0, so x equals minus c over a. It intercepts the y-axis when x is 0, and plugging in x equals 0, you get bx plus c equals 0, so y equals negative c over b. So given this formula, you plot these 2 points and draw the line between them, and that's a quick and easy way to graph the line. Now, there are special cases where lines are parallel or perpendicular. If 2 lines are parallel, they have slopes s1 and s2, then s1 equals s2. Okay, parallel lines have equal slope. And by the way, this symbol for equality, 2 little dashes right next to each other, were originally intended as parallel lines. So really, this is this formula motivated the invention of that symbol. Now, if there are perpendicular lines, if these 2 lines are at right angles to each other, and then S1 is -1 over S2, S2 is -1 over S1, and S1 times S2 equals -1. These are equivalent formulas. If perpendicular lines have negative reciprocal slope. Before I go on, let me give a brief proof of that. So imagine this line, the slope S1. We transport it parallel to itself until it goes through 0 by 0, and go over 1 to 1 by 0, up S1 to 1 by S1. So here, 0 by 0 and 1 by S1 are on this line with slope S1. Now we turn this 90 degrees, and 0, 0 stays the same. 1 by 0 turns into 0 by 1. And this distance S1 turns into a distance minus S1 to the left, because it's a rotation, and up turns into leftwards. So, okay, and so there, if this is 0 by 1 and you go S1 to the left, then this point here is minus S1 by 1. So these 2 points are on this line with slope S2. Minus S1 by 1 and 0 by 0 on the line with slope S2. But then that means that S2, the slope of this line, will be the difference in the y values, 1 minus 0, over the difference in the x values minus S1 by 0, like that. And after a small amount of simplification, S2 equals -1 over S1, and therefore all the rest follows. So parallel lines have equal slope, perpendicular lines have negative reciprocal slope. So for example, okay, find the equation of a line with slope 3 and y-intercept -2. Well, okay, here's a slope-intercept formula, 3x minus 2, and that's that. Now here's the one where it's a little more complicated. Find the equation of a line through 2 by 1 and 1 by 6. Now, if we just had one point and a slope, we could use the point-slope formula. Here we have to find the slope first. 2 by 1 and 1 by 6, the slope is, let's say, 1 minus 6 over 2 minus 1. That comes out to -5. Okay, so the slope is -5. Now, okay, we have a slope, and we get to use one of these 2 points. And if we did our slope right, either should work. There are 2 roots to this solution. Let's say 2 by 1. Then, well, looking back, the formula is slope, y equals slope times x minus h, all plus k. All right, so here, y equals -5 times x minus 2, all that plus 1. And okay, you want to, the next step is distribute, minus 5x, minus 5 times 2 is 10, plus 1 makes 11. So y equals 5x plus 11 is the equation of that line. Here we ask for the equation of a line through a point 1 by 2 and perpendicular to a line with equation y equals 3x minus 5. All right, this line, y equals 3x minus 5, has a slope equal to 3, as given by the slope-intercept formula. Now, perpendicular implies a negative reciprocal slope. Negative reciprocal 3 is minus 1/3. So slope is minus 1/3, it's through 1 by 2. So y equals minus 1/3 times x minus 1, all that plus 2. Here we are. And then after a bit of arithmetic, distribution, and then in combination, get y equals minus 1/3 x plus 7/3. That's the line through 1 by 2, perpendicular to the line y equals 3x minus 5. Now, I just did a bit of shortcut just a few seconds ago. I said the line y equals 3x minus 5. Well, I mean, a line is a figure on a piece of, is a figure in the plane. 3x minus 5 is an algebraic equation. They do match up. They're not the same exact thing, but I digress. Find the equation, the line through 1 by -6 and parallel to the line with the equation, x plus 2y equals 6. Well, okay, first we find the slope-intercept formula for this equation. So y equals 2x plus 6. X plus 2y equals 6 means that 2y equals -x plus 6, which means that y equals minus 1/2 x plus 3. So reading off slope and intercept, the slope of this line is minus 1/2. Now we want a line through 1 by -6 parallel to this other line. So it'll have the same slope, -1/2. It'll be through 1 by -6. So we use the equation y equals slope times x minus h, all that plus k. Slope is minus 1/2, h is 1, negative k is plus a k is plus a negative 6. And here too, we distribute and combine terms and get y equals minus 1/2 x minus 11/2. That's the equation of this line. Here they ask if here are 3 points, are they collinear? Are they on the same line? Well, one simple enough trick is to find the slope between these 2 points and the slope between these 2 points. And if they're the same slope, then they are collinear. And if not, then they are not. Okay, here we go. Difference of y's is 2 minus 8. Here you go. Well, all over difference of x is 1 minus 4. 2 minus 8 over 1 minus 4 is negative 6 over negative 3 is 2. Between these two lines, 8 minus 11 is a difference of y's. 4 minus 5 is a difference of x's, which comes from negative 3 over negative 1, which is 3. 2 does not equal 3, so no, these are not collinear. Here are three other points. 1 by 2, 4 by 8, and 5 by 10. Almost the same, except here we put in a 10 instead of an 11. Well, for these 2 points, we go through the same calculation and get a slope of 2 between these 2 points. For these 2 points, let's see, difference of y is 8 minus 10, difference of x's is 4 minus 5, negative 2 over negative 1 is 2. These are the same, so the answer is yes. Okay, this is a word problem. Driving 480 miles costs $380. Can you even do that nowadays? Never mind with probably the gas prices. Driving 800 miles costs $460. Let C be the cost of driving d miles, and we'll assume it's a linear function. C equals something times d plus something else. Something times d is basically the cost per mile, and this is the starting cost of just turning on your car in the first place, or having one with insurance, etc. Okay, 1,500-mile drive costs how much? Well, here we go. First, we have to find a formula. Find the slope and the intercept. The slope, this is going to be in dollars per mile, so it's 380 over 460 dollars, or 480 minus 800 in miles, which if we work it out, a bit of arithmetic is 1/4 of a dollar per mile, 25 cents per mile. Slope is a quarter, and let's say it goes through 480 miles by $380. So if we work it out, cost equals a quarter times d minus 480, all that plus 380, which after a bit of algebra comes out to d equals 1/4 d, c equals 1/4 d plus 260. All right, there's a formula. All right, so substitute 1,500 for d, and after a bit of work, it's $625. Okay, that's that.